Greetings, this is Chemistry with Nav. In this video we're going to take a look at some basic pH calculations. So let's just start off by recapping exactly what an acid is, and that it's a substance that forms H+ ions in aqueous solution. But we get strong acids and we get weak acids, and strong acids are those which fully dissociate into their ions. So if we take an example, let's use HCl, that's going to turn into both H+ and Cl- ions. So if we have that and we know that it's fully dissociated, then we can say that the concentration of HCl is equal to the concentration of H+. So whatever the concentration was of the acid given to you, let's say in the question, then you know that's your concentration of H+ ions, and your pH calculation is therefore straightforward, negative log to the base 10 of the concentration of H+ ions. So that's a fairly straightforward idea. With weak acids, they only slightly dissociate into their ions. So our typical example for this would be ethanoic acid, CH3, COOH, and because of this idea of the slight dissociation, we have an equilibrium which lies a long way to the left, which means that it's quite difficult to determine the H+ concentration. So we have to then look at an equilibrium expression, in this case the acid dissociation constant Ka. So Ka is going to equal the products over the reactants, so the concentration of CH3, CO- multiplied by the concentration of H+, all divided by the concentration of the acid originally. But we know that the ethanoate ion concentration and the H+ ion concentration must be equal, because this is an equimolar dissociation. And all that means is that if you go back up to the equilibrium, for every one ethanoic acid you get one ethanoate ion and one H+ ion. So there's equal moles of those two. So that allows us to make this substitution, that H+ squared is now in the Ka expression. So with a little bit of rearrangement, we end up saying that the H+ concentration is equal to the square root of Ka times the concentration of the original acid. And from there you can then say that pH is a negative log of H+. So just remember that with your weak acids they slightly dissociate, that's an important word to put in there, and that if you rearrange your Ka expression successfully you'll get H+ is equal to the square root of Ka multiplied by the original acid concentration.